Afternoon, everybody. Thanks for coming out, and hopefully the lunch won't kick in too badly and you all fall asleep on me, because I know I'm an exciting speaker. So that would be the only reason, of course, right? So I just wanted to talk a little bit today about using Bash to do some forensics tasks. Actually was here 2 years ago talking about Bash for some forensic stuff, and just kind of expanding on that a little bit. Just a quick bit about me. I'm a professor of digital forensics and cybersecurity at Bloomsburg University of Pennsylvania, which is in Bloomsburg, Pennsylvania. Surprise, surprise. Also the author of 4 books on forensics and cybersecurity. Also been known to build, maintain, fly, and teach others to fly planes, helicopters, and gyroplanes. So that's one of my side jobs that I like to do. Okay, so today I wanted to talk to you about something kind of simple. How do I find files using timestamps? I want to look at files and say, in this time range, there were some files accessed, modified, or created, and I want to easily get a list of those files. So, like many things, in Linux and Unix, they have this philosophy where you have tons and tons of tools that are really, really good at doing one thing. Right? And find is really good at, guess what? Finding things, right? So we're going to talk a little bit about that today. Now, some of the options for find include amin, cmin, and mmin, right? So that's access minutes, so was it so many minutes ago or more or less? Was it created or was it modified in this time range? So the way that these work, when you pass in these arguments to find, you can say plus and then a number. That means more than that many minutes ago. You can use just a number, and that means exactly that many minutes ago, which honestly, I can't imagine anyone using that feature. You're limiting yourself to a 1 minute window, and then there's minus your number, and that means less than that many minutes ago. Right? So here's the complication. Most of us can't just say, oh, yeah, last Tuesday, that was, this many thousands of minutes ago, right? That's not an easy thing to do, right? To go from a date and possibly a time to how many minutes ago that was. Well, guess what? The date utility comes to the rescue, right? What's the date utility do? It does date math, right? Very simply. And it's pretty cool. How many of you have ever played with the date utility? All right, a little bit, At a minimum, you can type date and it'll tell you the current date and time zone, things like that, but that's a trivial use of date. But you can use it in order to calculate a date and a time and move between different formats and all of that. It's very flexible, and it also accepts natural language. So I could say next week, Friday, and it would tell me when that is. I could say the 3rd Sunday of March, and it would tell me when that is. So it's a pretty cool tool. And of course, you can also give it just a date, timestamp, and it can calculate how many minutes ago that was. You might say, well, how does it do that? In the world of Unix, and therefore Linux, we have the epoch, which was January 1st, 1970, Universal Coordinated Time, formerly known as Greenwich Mean Time. Does anyone know why they picked that date? Because that was just before they invented Unix in the early 70s. So that's what they did kind of going forward. By the way, just as an aside, you know, you guys are familiar with Y2K. You know, some of you weren't born during Y2K, but you know, there was the big, oh no, the dates are gonna roll over because it's single or 2-digit years, and that was a big deal. And there was an issue where a 32-bit integer for seconds since this epoch was gonna roll over in like 2053 or 43, one of those dates. And people were like, oh no, what's gonna happen? Don't worry about it. They fixed that years ago. So we're good to like 2500 now. So 2500, I'm not really gonna be caring too much about date times. Well, it'd be nice if we have a lot of modern advances in, you know, physiology and being able to live for 500 years, but although maybe that's not so great after all, but okay. So what you do is you use the date utility to convert a date and possibly a time into seconds from the epoch, and then you subtract that from the current number of seconds from the epoch, and then you do this really hard math. You divide by 60, and that gives you how many minutes away you are, right? So, you know, here's the math. I have this little formula down here at the bottom, right? Now, this is using two little tricks in Bash. By the way, how many of you do any kind of Bash scripting? Like a little bit, okay, a couple of you. So these are a couple of cool things you can do in Bash. So the first one is right here where I say $sign and then parenthesis, and then I give it a command, right? And the command I gave it is date -d. -d says, don't look at the current date and time. I'm gonna pass something to you. And here's my start date. Now, I can give it a date, and then I tell it what is the output format. And the output format of +%s actually means, please tell me how many seconds from the epoch correspond to that date. Now, the little trick that I'm using here is that if you take a command and you put it inside parentheses that are preceded by a $sign that says, hey, Linux, go create a subshell, run this command, and whatever it outputs, please just paste it right into this other command. Okay? And I'm gonna do that twice. So here I have the current date and time, and then I subtract the difference between these two numbers of seconds, and then I divide by 60. Okay? And that leads me to the second little trick. If you take something and you put double parentheses around it and precede that with a $sign, it lets you do math. So that lets me do the math of here's a number minus another number, and then please divide that total, that difference, by 60, right? And that's how I'm getting my start minutes. Okay, so I wanted to show you a couple of simple scripts. The first one is just called between. And what does it do? It lets you look and say, hey, between these two dates, and you don't have to give it two date timestamps, you can give it just one, but you can say, if something is between these dates that it was either accessed, created, or modified, please tell me. Okay? So, like every good script, we will make use of a couple of things. First of all, we'll have a function called usage, and that is used so that if somebody screws up and they don't give you legit options when they try to run your script. It says, hey, here's how you run the script. We're going to use GetOps. GetOps is a nice thing that's built into Bash that allows you to easily process command line options and arguments. Okay? And we already talked about some of the Bash tricks that we have here. So I'm going to go ahead and run over to my editor. All right, so here's my script. Now in Bash, a line that begins with a hash or number sign, depending on who you are, is going to be a comment, or actually technically a hash starts a comment that ends at the end of the line. Now if on the very first line of your script you have a special comment where you have a hash and an exclamation point, that's what we call sometimes a shebang, and that defines an interpreter. In this case, user bin bash. And what that says is, hey, I want you to run this interpreter for this script and then pass every single line in the script to that interpreter. So if this was a Python script, I might have, user bin Python 3, Python 2, etc. as my shebang line. Then there's just a couple of comments. And then we have a usage statement. So the usage function, all it does is echo out some information. It says, hey, this is how you use this script, and this is what this thing does. Right? And here it says $0. $0 is the name of the thing you're running. $1 is the first argument you pass in, etc. Right? Okay, so a little overhead here. First thing we're going to do is we are going to get our options. And what I'm going to do is I am going to set certain variables. Right? So I have a variable called ACM. Is it access, creation, or modification times that I'm interested in? And I'm going to default to access. And then an action. Find allows you to have different actions. I can, by default, just print the names of the files that match. That's -print. I can do a print 0, which will print null terminated values, which can be advantageous if you're dealing with Windows subjects, which usually you are. Because Windows people have this annoying habit. They like to do things like put spaces in their file names, in their directory names, which wreaks havoc on a lot of your scripts. Right? So this is a way of dealing with that. Because you could use this script to simply print out some file names, or you could take a list of files and pipe it to another script in order to do more stuff. And we'll see a little bit later how to do some of that. Right? But in general, that's another kind of Unix, Linux thing where you have all these little tools that are really good at one thing, and then what you do is you kind of paste them together and you build the tool that you want. Right? Okay, so I have a little while loop here, and it's going to use getOps, and you give it a string. Where here I see S:, that says I have an option named S, and the colon says this option has an argument. In this case, the start date. I have an end date, which also has an argument, and then I have these options which do not have arguments. C, I want creation times, not access. M, I would like modification times, not access times. H, and H is going to give you help. And then Z says my action is now going to become print 0. I want null terminated output, please, not just new line terminated output. Okay, so we have this simple case statement in this while loop, and it's going to run through, And if it says, oh, you had S as your option, I'm going to set start date equal to the option argument. This is handled for you automatically by getOps. Right? Similarly for the end date, and the rest of these things are pretty straightforward. And then at the end of it, I have this weird looking thing where I say shift, and I'm going to do some math again, and I have opt-end -1. So opt-end is set by getOps, and it says this is how many things I processed. And basically what shift does is your first argument just goes away, and your second argument becomes the first argument. So this is getting rid of all those options, and it's getting the last option, the last argument, if you will. And that last argument is, hey, what directory did you want to look in to do this? Okay. And from there, it's actually pretty simple. I'm going to set my search directory equal to the only remaining argument. And I'm going to do the math for that start min, if you will. And if there was an end date, then I'm going to add that into my command line string. And then here, I'm going to once again use that one trick where I will say echo out all of this stuff and then just run it. Right? Now, by the way, you might be wondering, why did you have this weird thing where you've got all this stuff, you're going to echo it out, and then you're going to run it? And here's the problem. If I didn't do it this way, since I have things like plus a number, minus a number, guess what the shell's going to do? Oh, you had plus 4,000. I'll just change that to 4,000, which means exactly 4,000 minutes ago, right? So it's going to completely mess up my script. Which if you were writing this initially on a late night, you might go, oh, what's wrong with my script for a couple minutes? Then you were like, oh, I'm an idiot. That's what's wrong with my script, right? Okay, so let me, real quick, I'll just start here, and I'm just here in my home directory. Let me go to the directory where I have all these different files. And if I say, you know what, I want to run this script, I'm going to start, and I'm going to give it a date of yesterday. I'm not going to give it an end date. I'm just going to say yesterday. And I'll just do the current directory. Okay, so since yesterday, here are the things that have been accessed. That makes sense, doesn't it? Because it's my presentation and the two scripts that we're looking at. Okay. I could really go on. I could say I want to use modification times instead of access times, right? And now, oops, sorry. I put that in the wrong spot. Then it says, what got modified? Okay, my presentation, I did make a small tweak on it yesterday. What if I said instead, last Tuesday? And now I don't have so much. Of course, that was my start date. I didn't give it an end date, but you get the idea. So I can very easily use this now in order to say, hey, what has been modified in a certain time and date range. And you're like, Phil, okay, maybe that's slightly cool, but how is this useful for forensics? Well, where this starts getting useful for forensics is if I have an image of a system that I'm trying to investigate. Now I can look at that image and I can start pinpointing things, right? So for example, let me just very quickly, I'm gonna load up an image. So I have an image here, it's called Cybermen DD. Who are the Cybermen, by the way? From Doctor Who, right? How many people have ever seen Doctor Who? Right. And why is it Cybermen instead of Cyberman? What's scarier? More than one Cyberman. That's what's scarier. So, all right. So I have a pretty simple script here. It's just called mountimage.py. It's a little Python script, looks at the start of the disk image. I don't want to get into that today. If you have questions about that, definitely we can talk about it later. But I'm just going to run that real quick. And I'm going to mount this image. It's called Cybermen DD. And it found one partition and it mounted it. Right? So now what? It mounts it under a directory, media, in this case part 1, partition 1. And you can see this looks kind of like a Windows system here. I've got documents and settings, my recycler program files. Right? All right, so here's my trivia question for the day. What version of Windows is this that you're looking at? Any of you forensics people should be able to tell me this answer. It's Windows XP, right? And you know that because it has a documents and settings. It doesn't have users, which would indicate Windows Vista or newer. And it doesn't have a recycle bin that's called $recycle.bin. It's called recycler. But anyway, so now I could look at this image and do something similar. I could say, all right, let me rerun my between script. And I want stuff that's been modified. I'm going to have a start date of 2014, 10/01 with an end date of 2015/01 on media part 1. All right, and I found quite a few of these files were modified in that time frame. How many files were modified in that time frame? Since we're talking about Bash and cool stuff you can do in Bash, who can answer that question? Did you count it as it scrolled by? What's an easy way to count these? WC-L. WC-L is correct. So we'll just pipe that to WC-L. And that would be 20,449 files were in that time range, right? I could say, well, okay, what about ones that were created? Should be less, right? Ooh, that's interesting. I wasn't expecting that. What about modified? All right, a lot less that were modified during that time frame, about half. Right? Now, when you look at that output, you saw everything one per line. But if I was going to send this to another script, this is going to be a problem. Because again, you're going to have all these spaces in these file names. So I can easily use the -Z option. And when I do that, now everything has been null terminated, right? which again is probably what you want if you want to take these results and you want to pass it to another script. So what could I do, as far as like the other script? There's a lot of stuff I could do. I could pass it to something like file. How many of you have ever used the file utility in Linux? Yeah. So what does it do? It tells you what kind of file something is. So, Linux is a lot smarter about handling different kinds of files than Windows. Windows just solely looks at the extension, which is bad because you can easily hide information by saying, oh, well, that is really a PDF, but I'm going to call it a doc file or something else. And I try to load it on my Windows box and it says your file is corrupt. Whereas Linux looks at that and goes, I know exactly what that is. That's not just a doc file or a PDF. Let me tell you about who wrote it and how long it is and all this other metadata. So, that's a pretty cool thing. That's something I talked about a little bit last time I was here 2 years ago. But anyway, so I could use this, for example, let me just real quickly, I don't want to burn up all my time on this, but if I go back to my home directory and go to my downloads, actually I didn't really need to go there, but, and let me run my script. And I want to say, I'm going to have a start date of last month for my current directory. All right, so I got a bunch of stuff. And I could say, all right, I have all these files. How many of these files, though, were JPEG files? Right? And I could very easily find that out. Now, the first thing I'm going to do is I'm going to use the -Z option, again, because some of these might have spaces. I'm going to pipe this to File, and I'm going to say, hey, File, I'm going to give you this option. Actually, I'm going to make this, maybe I shouldn't go with this aside, because this is going to get a little bit interesting. All right, let me do this. File -- help. This is like Linux 101. If you don't know how to use certain options for a command, you can run that command with -- help, and it'll tell you a little bit about what it's going to do for you. Okay, and see, I just made this a little hard on myself. Okay, we might come back to this if we have time. But anyway, the point is, you can very easily use something like File. Let me just say yes, last week. All right, got one file. I'm going to pipe that to File. And it tells me, hey, it's just like text. But anyway, I want to move on here. So if I go back to my presentation, again, you can do things like use the file utility to look at different kinds of files that were modified in a certain amount of time, right? And again, it's going to use this awesome built-in database that's built into Linux and also give you some extra metadata. Okay? So that brings me to
this other script, which I just call filter.sh, right? And what does it do? Basically, it takes a list of files, and it's going to run the file utility, and then grep on each file that's passed into it, right? So let me do that real quick. Let me bring that one up. I guess I should have just gone right here. I was going to show you how to do it on the command line, but there's one little glitch. But okay, so same thing. We start with a shebang. And this one has different options. So I have -0, which means the inputs are null terminated. -O says please terminate the output with nulls. Maybe I'm going to pipe this to another utility. And then I can find different kinds of files. Now this is not an exhaustive list. Obviously you could easily add to this. So like PNGs, JPEGs, GIFs, all kinds of images, you know, MPEGs, etc. Once again, we have a usage function that pretty much just tells you that. And we're going to build a grep string. And we start with an empty string, and our output terminator is going to be, by default, a new line. And then we use getops again to process our different arguments. Now notice what we're doing here. If you said n, I'm going to add the string png pipe, which means or for grep. And if it was J, I'm going to add JPEG or. Basically, these are things I'm going to key off of in the output from file. Right? So I'm building up this string, and then there's a small problem. Right? So here we have null term is 1 for the input, and then we have /0 for the output, if that's the new terminator that I want. Now, the first problem we have is we have this trailing pipe at the end of the string. Right? So we need to get rid of it. So we do this little cool trick. In Bash, if you want to define a variable, an environment variable, you just have $, and the name of that variable. That says, please tell me the value of this variable. Right? That's the lazy way of specifying it. The safer way is $, curly bracket, name, close curly bracket. Now if you use that full syntax, there's also some manipulators that you can use, such as this one, : -1. That says, get rid of the last character, please. And then we have some if statements. I say if it is 0, this null terminator, then I'm going to read my file, and I'm going to do this. I'm going to say, here's my response from running the file command on my input file name. Right? And then I say, if echo my response piped to egrep -q, which means quiet. I don't want the output, I just want the results, please. Grep string dash. Dash says, don't look for a file name, just take my standard in. Then I'm going to echo -e, please, interpret this expression. No null terminator, no new line terminator, I should say. And I'm going to add my own terminator to the end of it. Right? Otherwise, this means, this else here, is that I have input values which are null terminated. And I want to do something about that. Right? So read normally looks for new lines to terminate the input. But you can give it a different delimiter, which is what I did here. I said -d. Here's your delimiter. And I know this looks weird, but this $, single quote, \0, single quote needs a null, right? Now, another thing about the bash shell, and all of the shells really, is if you put something in double quotes, it gets interpreted. So like here, where I have my file name in double quotes, that gets interpreted. If you put something in single quotes, it says, don't interpret this, just pass it along, right? And it's important to note that I have quotes around my file name here, and why is that? Silly Windows people, their little spaces in their file names. Otherwise, the file command would try to go after multiple files, and it would probably fail, right? Okay, and that's it. That's all there is to that simple little filter script. So let me go back here to this, and once again, I'm going to run a between command. And now I'm going to pipe these results to filter, and I will filter on, I don't know, let's say JPEGs. All right, oh, didn't get a lot of those. How about oh, it would help if I used the right options for my own script, wouldn't it? Because what didn't I do? I didn't tell my script, oh, by the way, I have null terminated stuff coming in here. There we go. Got a few more this way. So now what it's doing is it's giving me a list, and you can see a lot of these file names are going to have spaces in them as well, right? So now I'm able to look through 20-some thousand files and say, I only care about these particular file types, right? And again, I could take this and I could even null terminate this output, and then I could send it to another script and another script, right? So that's the kind of stuff that you can do with just very simple bash stuff, right? And I realize this is not like earth-shattering, but I kind of wanted to show you, even if you're kind of a beginner in bash, you can do some pretty cool and powerful stuff with really not a lot of work, right? I mean, this script is less than 100 lines long, and that's including all of the easy stuff like comments, there's white space in here, and all of that as well. So it's really, kind of interesting how quickly and easily you can hone in on certain kinds of files here. But okay, does anyone have any questions about these, or is there anything else forensic-y you want to talk about? Like if anyone cares, I can show you the little script I use to mount this stuff up, which is actually a Python script. I did think about trying to convert that Python script to a bash script, but honestly, it's not a great idea, because there's some things that bash is really good at, and there's some things that Python is really good at. So 2 years ago, when I was talking about using bash for some things, I actually took a Python script that I wrote that allows you to find files of different types inside of an image that you haven't mounted, and then print out the list of places where you found certain types of files. But if you try to convert that directly into a bash script, it turns out that it's horrible. The performance was really, really bad on the first hack, and the reason for that is that Python is really good at things like, hey, here's a file, read a sector, read another sector, read another sector. Bash does not like to do that. It was not really made for that. But all right, any questions or? You guys want to see that other script or don't really care? Just let me know. You want to see it? Yeah. Okay. I realize it's out of scope because it's a Python script, but okay. All right, here's my second trivia question for the day. How large is a standard sector? I'm looking at all the Marshall people. Forensics people should know the answer to this.
512 bytes.
512 bytes is correct. Or in hexadecimal, that would be 200. Okay, so this is just like a really simple script that's in Python, right? And what does it do? There's a couple of classes in here. I have a class for master boot record, MBR, and all this does is it uses a struct library in Python, and you just tell it, hey, here's the format of this thing. It's got 446 bytes of boot code, followed by this 1 byte, an active flag. Is this the thing to boot or not? Et cetera, et cetera. I'm not going to go through every field here. And similarly, and there's a bunch of accessors where you can say, hey, what is the partition type for partition 1, partition 2, 3, or 4, et cetera. Then we define a usage function. And then we have our main, and it says, hey, did you not pass me anything? I'm going to yell at you. I'm going to give you usage. And the usage is pretty simple. You already saw what you did. You just run the script, and you give it an image file, and it loads anything it finds. Right? I have a list of not supported partitions, things like an extended partition or a swap partition. And it says, hey, does this file really exist? And then it uses with open to open the file, reads in the first sector. That's the master boot record. And then it tries to create a master boot record object off that file. And then it says, hey, does that thing have a valid signature? If it does, it calls the pretty printer that prints out what it found for those 4 possible partitions. And then it just loops over the 4 partitions and it says, is this partition empty? If not, and it's not in my unsupported list, it's not a swap partition, then I'm going to create a mount path, which is just /media/partition and whatever partition number it was. And I say, hey, did that thing exist? If not, please make that directory. And then I give it a bunch of mount options. Now you can easily do this on the command line, by the way. You just run fdisk on the image, you find the starting sector, that's all you really need to know. And the options you give it are loop. Loop says, I am not an actual device, I'm just faking it. I'm just an actual file. RO, read only please. No A time, please do not update the access timestamps, which is more relevant for Linux partitions than Windows. And then the offset. So the offset says, where does this start? Normally when you mount something in Linux, you're mounting a partition and you're mounting something that starts at the beginning of that partition. Well, here we have a file, so you have to go to an offset into that file. And by the way, this last little bit, like if you were to download scripts, say from some of my books, for example, you would download the script. This last little part won't be there. I should probably put that on GitHub and update it, but this is something that's kind of new, where in the later kernels, if you had more than one partition and you ran the script, the second partition would fail. And the reason for that is the way they do the loop-back devices in Linux has changed recently. And you'll get this weird error about overlapping partitions. So I had to add a size limit option to say, okay, where does this thing end? Right. And then we create a string and we say mount, and here's my options, and that's it. Right. And this ends with a little Python trick. How many of you are Python users in here? Okay. How many of you know about this little trick? Double underscore name, double underscore equals, double underscore main, double underscore. All right. So this is a little trick where if you run a Python file, it will define this variable, double underscore name, double underscore, to be equal to this value. And why is that useful? If you have a script, maybe it's some sort of a library that you're going to import into other things, and maybe you have a test function where I just want to run it and make sure the library is operating correctly in the environment in which it's going to be run, I can easily use this trick in order to do that. And that way, it only runs it if I run the file directly and not like, I mean, yes, you could say main and run it, right? But this is a lot cooler, right, to do it this way. All right, any questions? Yes?
I noticed you have, sorry, GPT is not supported, so I'm guessing that this script wouldn't work with like a Windows 10 or 11 installation because they use GPT instead of MBR.
This particular script, no, but I have two other scripts that will do extended partitions and GPTs. Now, I could have done that in one big happy script, and I just chose not to. But now it turns out the most complicated one is the extended partitions because of that. It's a nasty kludge. You guys probably know this, but if you want more than 4 partitions, if you're using master boot records, you have extended partitions which are nested inside of, you know, actual partitions, and it's like in the rabbit hole you go. It's like that movie Inception, which is kind of old now. It's like, am I still dreaming, right? Which level am I at? And you have to kind of chase down the rabbit hole. But if you look at the script for GPTs, GUID-based partitions, by the way, GUID partition tables is what GPT stands for. That is way simpler because it's all nice and orderly. But that is a good question. All of those are available on the different websites, so they're in different levels of messed up, and I apologize for that. I do not control the websites, unfortunately. The publisher of my last 3 books does, and there's been issues with some of that. But if you have a hard time grabbing stuff off of those sites, feel free to like email me or whatever, and you know, I can help you out with that. But yeah, so GPT's way easier though. Any other questions?
See you then.